Good afternoon. We are going to take notes on Trig point 6, which is in Unit 11 of Pre-Calculus. For the notes today, you're going to need your graphing calculator. I'll be using a TI-84 Plus. And we are going to do some drawing. So you might want a ruler, maybe a little graph paper would be good as well. Mainly what we're going to focus on is some of the different styles of questions that you're going to get in this next section. So we're going to go example by example and learn along the way. So our first one is given A, which is sine of pi over 6, obviously radians, B, cosine of 45 degrees. We're going to get values with and without a calculator. So let's start with A. First, let me draw a line. There we go. Okay, sine of pi over 6. So first thing you need to recognize is there's no degree symbol, which means this is in radians. So when you get to your calculator, you're going to need to push mode, toggle down to the third one, so it's highlighting radians, push enter, and then quit is blue here, so second quit out. Now you can put in radians angles and you'll get the correct answer. So sine of pi is here, so blue and there, so pi divides 6, and you want to get into the habit of closing it because later on we'll be doing more complicated things in the calculator, and you want it to find sine of pi over 6, not sine of pi and then divide by 6. That'll give you a different answer. So this is a nice tidy 0.5. So that's 0.5 with the calculator. Okay, so without the calculator, sine of pi over 6 is the same as sine of 30 degrees, which hopefully you've memorized. That equals 1/2. And that's the form you answer without a calculator, is in the fractional form. Okay, pretty straightforward. Let's go on to B, which is cosine of 45 degrees. So to find this on your calculator, we need to switch to degrees. So push mode, toggle down, toggle to the right so degrees is highlighted, press enter, and then quit out. Now you can do cosine of 45, and you get a nice long decimal. When you are doing calculations with cosine and sine, if you're going to use it for anything, you need to go 6 decimal places. If it's just a straight up answer, typically 3 or 4 will do it. I believe on your assignment it's 4. So we're going to round this to 0.7071. And then again, I'm going to put this in red. If you're using the number again, you want to go a minimum of 6 places. That's not even like the maximum. That's a minimum of 6 places. So in that case, it would be 0.707, 107 when you round it. That's what you're going to want to write down so you can use it. Okay, so now without a calculator, cosine of 45 degrees is 1 over radical 2, which of course you're going to rationalize into radical 2 over 2. So decimals that are rounded are good with the calculator. Ratios that are rationalized are what you do without a calculator. Now, sine, cosine, and tangent are easy because there's buttons on your grapher, sine, cosine, and tangent. You'll notice that there is no cosecant, secant, or cotangent button. You can find it, but most people calculate it on their own. These little blue buttons here, sine to the -1, cosine to the -1, tangent to the -1, these can be confusing because they look like reciprocals, but they're not. They're actually arc tangent, arc cosine, arc sine. Those are not buttons we can use for the other 3 functions. So let's do cosecant of 30 degrees. Now we know that cosecant is 1 over sine. So we can write this in terms of sine, 1 over sine of 30 degrees. So when you calculate this, you can do it one of 2 ways with your calculator. You can do, we're back in degrees, which is okay because our mode is degrees. So you can do 1 divided by parentheses, sine of 30, close the 30, close the bottom. So that's one way to enter it. Get 2. The other way to enter it is to find sine of 30, press enter, and then flip it, which means you're going to raise it to the power of -1. So what does that mean? You're going to go sine of 30, and then when you're done, you're going to raise it to the power of -1, which will flip it. So we take that, we use the caret to the power of -1, and we get our 2. So you can do it with the 1, or you can find sine of 30 and just flip it using a -1 exponent. And of course, this is one you memorize, so it would end up being 2 anyway. But that gives you 2 ways to go about doing it. So remember your reciprocal values, just to kind of review them. Cosecant is 1 over sine. Secant is 1 over cosine, and cotangent is 1 over tangent. So when calculating with those 3, you're going to need to use reciprocals. Okay, so that's our first example, is how to use a calculator as well as doing things by hand, how to find the 3 that aren't on the face of the calculator. So we're going to go to example 2. Example 2 says, let's let theta equal pi over 3. Obviously, that's radians, even if they don't say it. You need to find the point that this corresponds to. Okay, so first thing that we want to do is make a little graph to get our brain on right. So draw yourself a pair of axes. You can scoot the y over to the left. And we are going to try to find the point that will create that angle. So draw your right triangle here. This is your theta, which is pi over 3. And the point we're looking for is an xy point. Now, of course, in the triangle here, your x-coordinate going to the right is your adjacent side. Your y-coordinate, which is across from it, is your opposite side. So to find a point, we need a trig function that uses opposite and adjacent. The most logical choice is tangent. Tangent is opposite side over adjacent side. So what we can do is write an equation using tangent and opposite and adjacent. So here we go. Tangent of pi over 3 equals, okay, so this is one of your memorized values. Tangent of pi over 3 is the same thing as tangent of 60 degrees, which is radical 3 over 1. And radical 3 over 1 is your opposite over adjacent. So, since tangent is opposite over adjacent, the opposite would have to be the radical 3, and the adjacent would have to be 1. So your point is 1 to the right and radical 3 up. Okay, so sometimes there are multiple points that are possible. What's important to realize is where tangent is going to give you positive values. But most of the time, they're just going to have you do the 1 point. 1 to the right, radical 3 up. If they ask you for multiple points that share that same ratio, so not just 1 point but others, remember that a ratio can always get multiplied. So if you need other points, you need to get multiples. So it's like you take the radical 3 over 1, you can multiply it by any multiple you want, 2 over 2, that's 2 radical 3 over 2, which would then be the point 2 to the right, 2 radical 3 up. So that's how you get multiples of the same point, is simply by multiplying the ratio by what multiple you want. Okay, flip the page. We're going to go to more of a story style problem. So this is example 3. Okay, so here's our problem. You are standing 25 feet from a tree. The angle of elevation to the tree is 30 degrees. How tall is the tree? All right, so first thing you need to know to be able to do this question is you need to know what an angle of elevation is and an angle of depression. So an angle of elevation is an angle that starts horizontal and it goes up from there. That is your angle of elevation. Horizontal and then up. An angle of depression, on the other hand, still starts horizontal, but it's measured from horizontal down. So angle of elevation means you're looking up at an object, up here. Angle of depression means you're looking down at an object. And the horizontal can either be, ground or a road or something, or, if you're standing on the edge of a cliff looking up at a plane, your horizontal can just simply be a dashed line that you measure from, your angle of elevation to the plane. So the horizontal line does not have to actually exist. It could be one that you draw onto the situation. So let's draw this situation. It says you're standing 25 feet from a tree. Okay, so here's our ground. And then we have a tree. There we go. We'll make it a Christmas tree. There we go. So you have a tree, and you are standing. There you are, with a big smile, because it's PreCalc. Woohoo! You're standing 25 feet away from the tree. Now, here's some assumptions you have to make. Unless they give you your height at your eyeball, if they give you your height at your eyeball, you got to measure the angle of elevation from your eyeball. If they just say you're standing, you measure it from your feet, and it measures to the foot of the tree. And we assume that the tree is straight up and down, not crooked or super wide. So the angle of elevation to the top of the tree here is 30 degrees. Okay, so we're trying to figure out the height h of the tree. Well, what you'll notice is that the tree and you make a right triangle. Again, we're assuming the tree is straight up. So we have values of h that we're trying to find and 25, which we've been given. So that would be opposite and adjacent. So your logical choice of trig functions is going to be tangent, because tangent of theta is opposite over adjacent, and we're trying to find the opposite side. Okay, so filling this in, tangent of 30 degrees equals opposite, which is h, over adjacent, which is 25 feet. That is your equation. Now here's where it depends on what they want. If they want an exact answer, you're going to just solve for h. So you end up with h equals 25 tangent of 30 degrees, and that will be in feet. That's your exact answer. If you're looking for a rounded answer, then you need to use your calculator or your memorized angles. So this is exact. I guess this should go one more step. Tangent of 30 degrees is 1 over radical 3. So 25 times 1 over radical 3. Your height ends up being 25 radical 3 over 3 feet. Yes, that's better. If it's an angle you know, then yes, sub it in and get your answer. If it's not an angle that you know, like 62 or 85, you can just leave it in this form if you can't go any further without a calculator. So exact is in general without a calculator, whereas rounded is with a calculator. So using your calculator, you're going to still solve for h. That hasn't changed. The difference is you're going to type it into your calculator. So make sure you're in degrees. Good to go. So 25 times tangent of 30 degrees. That gives you 14.433. And in terms of feet, rounding to 1 decimal place is logical. So 14.4 feet, and I'm going to change this to rounded. So in both cases you solve for h, it's just in one case you shoot it through your calculator, and the other one you don't. Those are your two answers. Okay, so the last thing I want to mention before closing this out, this isn't a very long section of notes, is what do we do with arcs? And we're not going to do a ton with this today, but it comes up, I think, once. Let's say that sine of theta equals 1/2, and you're trying to find theta. Now, you already know that theta is 30 degrees, so this one's kind of a no-brainer. But if you have to find theta, what you do is it's called an arcsine, and you can write it one of two ways. You can write it with a -1 for the entire left and a -1 for the entire right. That's one way to do it. Or you can actually write arcsine of sine theta equals arcsine of 1/2. When you arcsine a sine, it cancels out, and all you have left is theta. So theta equals arcsine of 1/2. Your arc button on your calculator is the blue one here. Those aren't reciprocals, they're arc. So we're in degrees, so if they want the answer in degrees, we're in the right mode. So you'll go arcsine of 1 / 2, and it comes up with 30 degrees. Now again, you wouldn't use this on one that you actually know, because you already know sine of 30 degrees is 1/2, so that's kind of a no-brainer. But if it is indeed a weirdo angle, you're going to want to be able to put it into your calculator, and the purpose of the arc button is specifically to get a theta out of a sine. In fact, arc buttons are the only way to get rid of the sine and pull the theta out. If it's a cosine, you arc cosine. If it's a tangent, you arc tangent. If it's one of the other three, you're going to have to replace it with like 1 / sine and solve for sine first, and then arc both sides. Okay, that's everything. We'll get more into arcs later. Have a good afternoon.